Hi guys, so we're going to go over the nth term of an arithmetic and geometric sequence. So here are the formulas, and just make sure that when you write a formula, you know what each variable represents. So if I'm looking for a sub n, a represents any term in the sequence. So sub n means that I'm looking for, let's say in my example, ninth term. So n would represent 9. For n itself, it represents the total of number of terms I'm dealing with. And in arithmetic sequence, we have a common difference, so that's what the d represents. There are two formulas. You'll find the same number, though, for an arithmetic sequence. And if you're using the second formula, the value of c is a sub 1, which is the first term, minus the difference. So remember, a represents any term in the sequence. So a sub 1 means the first term in the sequence. So I'm just going to make a note of that as well. And when you have a geometric sequence, you have a common ratio, meaning you're multiplying the same constant value to get from one number to the next. So using the example here, if I look at number 1, to get from one number to the next, I have a constant ratio of 3, meaning to get from one number to the next, I'm multiplying 3. 5 times 3 is 15. 15 times 3 is 45. So the first thing I'm going to note is that this is geometric. It has a common ratio of 3. So now I know what formula to use. So using the formula a sub n equals a sub 1 times r to the n minus 1, the example in the directions in the example ask for the ninth term. So that means I'm going to replace n with 9. So a sub 9 means the ninth term equals a sub 1, which is the first term of my sequence, 5, times the ratio, which is 3, to the n minus 1 power. So n, again, we're going up to the ninth term, so 9 minus 1. And then from here, you have 5 times 3 to the 8th power. So biggest mistake I've seen so far, remember your PEMDAS. Do not forget your algebra. We do not multiply 5 times 3 first. In PEMDAS, exponents always come first. So you take 3 to the 8th power first, giving you 65, 61, and then you multiply it by 5. So then the ninth term will equal 32,805. And then if I look at the second sequence, there is a common difference because to get from one number to the next, I am constantly adding 4. So common difference means I'm adding or subtracting the same value again and again and again. So I'm going to make a note that this is arithmetic and that there is a common difference of 4. So I could use either one of the formulas. So let's say I choose the second one. A sub n equals dn plus c. So a sub n, or a sub 9 in this case, equals 4 times n, again, I'm going to the ninth term, plus c. And then sidebar, c equals the first term minus the difference. So I'm going to do the work up here. C equals to the first term minus the difference. The first term in that sequence is 7 minus the difference, which is 4. So c would be 3, positive 3. So I'm just saying positive 3 because if it were negative, you would put plus negative 3. So don't think that anything has to happen if the sign's negative. You're just going to bring it down exactly as it is. So a sub 9 equals, PEMDAS again, multiply before you add, 36 plus 3, which would give you 39. And then let's say I were to use the second formula as well. So let's say I were to use a sub n equals a sub 1 plus n minus 1 times d. So, sorry, it's going to get a little cluttered there. A sub n, so again, n is 9, equals a sub 1, which is 7, plus n minus 1, so 9 minus 1 times d, which is 4. So in PEMDAS, I'm using parentheses first. I'm bringing everything else down. I'm bringing down the 7. I'm bringing down the plus. 9 minus 1 gives me 8. Bring down the 4 in parentheses. And I multiply first. multiply before adding. So I get 7 plus 32. And it still gives me the same answer of 39. So arithmetic, you have two formulas, but it really doesn't matter which one you use. You're going to get the same answer. So use the one you're more comfortable with. So I hope this helps, guys.